Okay, now we move to solving problems in this chapter, describing data numerical measures. Of course, as you can see, the first problem is given the following data of hours per day that a sample of 11 bank employees spend working on the computers. So here we have this sample data of 11 bank employees, of course, spending times working on the computers. These are the hours per day the computer or the bank employees spend working in the computers. For instance, you have 11, of course, employee, and they spend, each one of them spend the following amount of hours: 4 hours, 5, 7, 4, all the way. Okay? Now, first part of the question, calculate the mean. Now, since, first of all, you ask yourself, it is a sample. Therefore, the arithmetic mean has its own symbol, and so we have to use this formula, x bar. X bar is the symbol for the arithmetic mean of the sample. Okay? So when we have a population, we use a mu. When we have a sample, we use x bar. So x bar is the summation of all these values, and we divide by the number of observation, which is 10. We have 11. We have 11. So we add all of those values and we divide, of course, by 11. Okay, and we come up with 5.72. So 5.72 is the arithmetic mean of this sample. What do we call the value computed in part 1, in this part, or in part A actually? In part A here. So it's called a statistic. Why? Because it is, any, value of a sample, any computed value of the sample, whether it is arithmetic mean, median, mode, if it is related to a sample, it is called a statistic. Okay? And if it is related to the population, it's called, of course, a parameter. Now, calculate the median and the mode. You remember the median. To calculate the median, first of all, you have to arrange the data from smallest to largest, or from largest to smallest. And then if the data is odd, you take the middle value in that arrangement. And if it is even, then you take the middle two and get the average of these two values in the middle. So now here we have, as you can see, 11 observations. Therefore, we have an odd number of values. So we take the middle one in the middle. So as you can see, of course, these are the data. So we get here 5 to the right, 5 to the left, and this is 5. 5 numbers to the right of the middle, and 5 numbers to the left of the middle value, the center of the data. We come with 5. So the median is 5. It is mode. What is the mode? Of course, the mode is the value that occurs the largest number of times. Okay, or it has the value that exists with more, or it has, or the value it repeats the highest number of times. So if you look at the data over here, we notice that 5, is stated 3 times. Okay, so since it exists, the highest number of times in the data, then it is the mode. So the mode is 5. It repeats 3 times more than some other values such as 7, which repeat 2 times. Okay, great. Now we move to problem 2. Problem 2 says, given the following population values. So now the question is telling us that we have a population. Okay, and these are the values. Okay, now the first question find the arithmetic mean, median, and mode. Okay? Now, of course, here we have to, the mean, as you can see, here we have to use the mu because we have population. So it is almost the same, of course, the same formula. However, the symbols are different, the notations are different. So here we use the mu to denote. Okay, now mu, since we have a population, so we're going to use, basically it is the same formula. However, the symbols of the formula are different. So we're going to use the mu instead of x bar, and we're going to use n capital instead of n small to represent the formula of the mean, population mean. As you can see, it's over here. Mean, mu, it's sigma x by x, sigma of xi, which represent all values, over n. Sigma refers to the summation of all the values in the population. So we add all the values and divide by 10, so we come up with 3.25. When you do that, you come up with 3.15. This is the mean of the population. Now, the median, as I said, we arrange the data either from the smallest to the largest or from the largest to the smallest. And since we have an even number of values, then what we do after the arrangement, we take the middle two values and we get the average of the middle two values. That is, we take the middle two values, divide by 2, and we come up with the median of the data. The median, as we said, 3.3. So the median is going to be 3.2 plus 3.4 over 2, and we come up with 3.3, which is the median of the data. The mode, as you can see, the mode, of course, the mode is the value that repeats the highest number of times. The value or the observation that exists the highest number of times in the data. So here, as you can see, 3.7 exists 3 times. So therefore, 3.7 is the mode. Comment on the skewness of the data. Of course, as you remember from the discussion of the chapter, that whenever in the distribution, we're talking about the relative positions of the mean, median, and mode. So when the mean, as you can see here, the mode is greater than the median and is greater than the mean. So in this condition, when the mode is the largest of the 3 measures of location, then we say that we have negatively skewed distribution. We have, of course, non-symmetrical distribution. It is negatively skewed distribution. It's like this one here, skewed to the left. Of course, problem 3, a random sample of the grades of exam 1 in PSTA. PSTA, the class that you are taking in statistics. These random sample of the grades, are stated below, which are these: 95, of course, 95, 87, 65, 76, 64. All these are the grades in exam 1, of course, of selected students taking PSTA, whatever, 205 or whatever number of that course. Calculate the mean, median, and mode. Of course, the mean, all we have to do, because we have a sample, we use X bar, okay? We sum all of those, okay? And then we divide by the number of observation in the data. And when we do that, of course, we come up with 78.1, which is the mean of the sample, okay? Now, the median, as I said, either you arrange the data from the smallest to largest, or from largest to smallest. And if the data is odd, you just choose or select the middle one, okay? And if the data is even, what we do, we just select the middle two and get the mean of these two observations. So here, as you can see, we have an even number of values. So what we do, we arrange the data, as you see over here, from smallest to largest, okay? And then we take these middle two values, 76 and 79, we add them, okay? We get the average of these two values, and then we, of course, we add them, divide by 2, and we come up with 77.5, which is the median of the data. Now, as far as the mode, of course, the mode, the mode here is the value that exists the highest number of times, and it is 76. As you can see, 76 exists, 2 times more than any other value. Therefore, it is the mode. Okay. Now, the question B, part B of the problem, compare the mean, median, and mode, and comment on the skewness of the distribution. Of course, we just solve the question like this. Of course, we just compare the mean with the median and the mode, and to see if the mean is the largest of the 3 measures, then we say it is positively skewed. If the mean equal the median equal the mode, then we have symmetric distribution. If the mode is the largest of the 3 measures of location, then we have negatively skewed. We'll look over here and compare them. We say the mode is 76, the median is 77.5, and the mean is 78.1. So as you can see, the mean is the largest of the 3 measures of location. Therefore, we have positively skewed distribution. We have a positively skewed distribution, as you can see, positively skewed distribution. Now we move to, of course, part C, calculate the range in problem 3. Calculate the range. The range is the formula of the range, which is the simplest measure of variation. The range is equal to the highest value minus the lowest value. So we subtract the lowest value from the highest value to come up with the range. Here we did that. The highest value, as you can see, is 95, and the lowest value is 59. We do that, we come up with 36. So 36 is the range. Now it's saying here, can we consider the range as the best measure of dispersion? The range is the simplest measure of dispersion. However, it's not the best measure of dispersion. Why? Because it takes into consideration only 2 values, the highest value and the lowest value. It does not take into consideration all of the data. Therefore, this is one of the weaknesses of the range. Calculate the variance and the standard deviation. Of course, show your calculation. Remember, we have a sample. Therefore, the equation of the sample is this, S squared. S squared is used to stand for the variance of the sample. So S squared is going to be equal to summation of x minus x bar square over n minus 1, because we have a sample, we have to divide by n minus 1. And the standard deviation is the square root of the variance. Now, how to find step by step the value of the variance? So what we do first, we have a column x, which is the values of the observations. So we have a column consists of all values of the observation, 95 all the way to 79. And then we put another column of x bar, which is 78.1. Now, what we do, before we calculate x minus x bar squared, we have to calculate x minus x bar first. Okay? So we do that here. Another column, the third column, x minus x bar. So we get 95 minus 78.1, we get 16.9. 87 minus 78.1, we come 8.9. 65 minus 78.1, we get minus 13.1. 76 minus 78.1, we get minus 2.1. And we do that for all the values here, okay? And we come up with these values, of x minus x bar. Now, the fourth column is x minus x bar squared. So what we do, we just square those values, okay? So 16.9 square, 8.9 square, minus 13.1 square. Okay, we square all of them and we come up with all these values. These are the values of x minus x bar square. Okay, now what we do, because the formula says summation of x minus x bar square. This is here x minus x bar square. So what we do here, we just, what we do, we just sum all those numbers and we come up with 1394.9. Okay, this is the summation of the x minus x bar square. So now we plug that in the formula. S squared equals summation x minus x bar squared over n minus 1. So 1394.9 over 10 minus 1. N is the number of observation in the data, which is 10. So 10 minus 1, we get 9, and we come up with 54.98. This is the variance. Now we want to calculate S, which is the square root of S squared, which is 12.449. This is, how we calculate the variance. So in the exam, okay, if you were asked to calculate, the variance, you follow the steps here to calculate the variance, step by step. First, a column of the number of observations, a second column of the mean, a third column of x minus x bar, and the fourth column is x minus x bar squared, and then you sum the sum of x minus x bar squared, and you plug them in the formula of the variance to calculate the value of the variance.